This screencast is going to provide you some information about chemical equations. Chemical equations are a way of summarizing information. So in a math problem, you might have a word problem that you're going to be putting into some type of equation. So this is just to kind of take a whole sentence. Puppy grows by 6 ounces every week from its birth weight of 2 ounces. Write an equation to describe its growth. So you would take that, and a math equation would be that growth equals 2 plus 6x, where x is the number of weeks. So that's taking a math problem and turning it into an equation. Instead of having numbers and variables like you do in math, in chemistry, it's more like writing. The letters are represented by symbols. We put symbols together to make chemical equations, just like we put letters together to make words. We put words together to make sentences, which is how we write a chemical equation. Okay, if we have a description of a chemical reaction that is this: water breaks down into hydrogen gas and oxygen gas when electricity is passed through it in the presence of an electrolyte. That's a complete description, but for most purposes we summarize by writing a chemical equation. So we are going to write our formulas. So water, you know, is H2O, the arrow for yields to show what it's breaking into. And then we're going to have hydrogen, which is H2, and oxygen, which is O2. Remember from our bonding unit that these two elements like to have a partner to complete their outermost rings, so they'll always have 2's with them when they're in the element form. And that is your initial chemical equation. Chemical equation, again, has the parts. So the beginning here are called reactants. The ending is called the products. So that one's probably the easier one. So if you can remember products or what is produced, then you can remember hopefully that the other one is reactants. So chemical reaction, reactants. And then the arrow is red, yields. Equations need to be balanced due to the law of conservation of matter. So law is something that has to be followed. Conservation means to not use up. So when you're conserving resources, you're not using them up. And matter, of course, is anything that has mass or takes up space. So all of these have to be conserved within the chemical equation. To conserve, we need to look at the types of atoms we have here. So you'll see that we have 2 hydrogens on this side and 2 hydrogens on the product side. So that is already balanced. For oxygen, you're going to see there's 1 oxygen on this side, but there's 2 oxygens on this side. So we can't just create another oxygen. It has to come from somewhere. And this is where balancing is going to come in. And we're going to talk about how to balance equations in another screencast. But just so you have an idea, I have a video link for you to watch.
If we connect an electrolyzer filled with distilled water to a source of direct current, we can observe a slow evolution of gases. After some time, we notice that the volume of the gas released at the cathode is double that of the gas formed at the anode. To identify the gaseous products of the reaction, we collect each gas in a test tube and check its behavior in the presence of a glowing splint. The characteristic cracking sound proves that the gas released at the cathode is hydrogen. The ignition of the glowing splint is evidence that the gas collected from the anode is oxygen, which supports combustion.
This is a snapshot of the picture of that apparatus after it had reacted for a while. If we draw a straight line here, you can see that this region and this region are going to be equal, and this region down here is about twice of what we have over here. So there's a 2-to-1 ratio of hydrogen. And from the formula of water, you'll see that there's twice as much hydrogen as there is oxygen, so that's not surprising. The way we represent that in the equation is as follows. Okay, we will add numbers to this. So you can see that we get twice as much hydrogen as we do oxygen. This number here is called a coefficient. Okay, this number here would be a 1. We don't normally write 1s, just like we don't write H2O1 in the formula. We don't put 1 in for a coefficient. But we actually need 2 water molecules to break down to do that. To see a visual of what's happening at the molecular level, I'm going to insert an image. Okay, and you can see here very visually, so twice as much hydrogen. Okay, as you can see here in the image, in order for us to split this H2O apart, we get 2 hydrogens from just this one. So this water molecule can give us both of these hydrogens here, but we only get 1 oxygen molecule. So in order to get 2 oxygens, the O2, we need 2 water molecules. This one and this one are going to give us this oxygen, and that's why we need 2 water molecules, and then we get 2 hydrogens. So again, 1 from this molecule, and 1 from this molecule. And this is what is called the balanced equation for the decomposition of water. And it obeys the law of conservation of matter. And again, I'll show you more about that in the next screencast.